question 1, specifically A, we got x equal function x equals to 2x to the power 4 minus 11x to the power of 3 plus 17x squared. So I will show you how to find the critical numbers for this function. First, we need to find where the graph is flat. To do that, we take the derivative. So using the power rule, the equation becomes 8x to the power of 3 minus 33x to the power of 2 plus 34x. Next, we set this new equation to 0. We can immediately see that every term has an x in it. So we can actually factor that x out. That gives us our first answer right away, which is x equals to 0. So in step 3, now we are left with a standard quadratic equation for the rest. I plug the numbers into the quadratic formula, which is here. It gave me two values, 2 and 17 over x, which is right here. So this is what we get. So the function has three critical numbers as shown, which is x equals to 0, x equals to 2, and last but not least 17 over 8, which is actually 2.125. So that's all for 1A.
So we move on to our next question, 1b, and that is we have to find the point of which fx has a relative extremum. So first, I found the first derivative f prime x, which is 8x power of cube minus 33x squared plus 34x. So we set this into equal to 0, where we have the critical points. We got x equal to 0, x equal to 2, and x equal to 17 over 8. Next, we find the second derivative, where f double prime x equal to 24x squared minus 66x plus 34x. And I use this to test the concavity of each critical point. So for x equal to 0, we will get the value of 34, which is more than 0, which is a local minimum because the graph is concave outward like up. So the point is a local minimum. For x equal to 2, we have when we sub in the value of x, we will get the negative 2, which is less than 0. When it was the less than 0, the graph will concave down and the point will become a local minimum. For x equal to 17 over 8, when we substitute the value of x, we will get the 17 over 8, which is more than 0. So the graph will concave outward, and we will have the local minimum extremum for x equal to 17 over 8. And then we have to search for the coordinate, where when we substitute the value of that we got where fx equal to 0, we have to find the point of y, where we need to substitute the value of x into the fx into our original function, where when we substitute the value of 0 into our function, we will get 0, where the first point of extremum we got the 0 of 0. When we substitute the value of 2 into our original function, we will get the coordinate 2 and 12 for our second point. And then for our third point, when we substitute the value of 17 over 8 into our original function, we will get the value of 11.99. We can't have the same value of we can't have I don't round this up because we can have the same value of like our second coordinate, which is 12. So for point 17 over 8, we will get the 17 over 8 and 11.99. Thus, uh, that is all for our relative estimate point. It's 0 and 0, 2 and 12, and 17 over 8 over 11.99.
Looking at part C, we need to find the intervals, where the function is increasing or decreasing. To do this, we use the critical numbers from the previous steps, 0, 2, and 17 over 8 to set up 4 test intervals on the x-axis. By testing a value in each interval using the first derivative, we determine the behavior of the graph. The function is decreasing on the interval from negative infinity to 0, and again between 2 and 17 over 8. In these areas, the derivative is negative, meaning the graph is moving downward. The function is increasing on the interval between 0 and 2, and for everything greater than 17 over 8. In this section, the derivative is positive, and the graph is moving upward. This table serves as our roadmap for understanding the overall shape of the curve before we plot it. Finally, for part D, we use GeoGebra to plot the function fx equal to 2x to the power of 4 minus 11x to the power of 3 plus 17x to the power of 2. This graph confirms that our analytical calculations are correct. As we can see on the screen, point A at 0, 0 is our first relative minimum, where the graph stops decreasing and starts to rise. Point B at 2, 12 is our relative maximum, where the graph reached a peak. Point C at 17 over 8, 11.99 shows our second relative minimum. The graph clearly shows the function dipping at the origin, rising to peak at x equal to 2, and then having a very slight drop at x equal to 17 over 8 before rising again towards infinity.
Hello, this is Akram, and I'll be explaining question number 2. So first of all, we should let L equals to length of rectangle and W equals to width of rectangle. So given that area of a rectangle is the length times with the width, we can conclude that LW equals to 50 inches square, all right? and two sides are being lengthened at the rate of 2 inches per second, indicating that our dl and d over dt is 2 inches per second. So it's asking for dp per dt. So for question A, when the increasing side is 5 inches, you should first of all differentiate both sides. All right. So for d over dt, you use product rule because it involves the multiplication of two variables. So this is the formula for product rule. So you let u equals to L and then differentiate like normal, B and then B prime, differentiate, and then use substitute these values into this equation, in which you'll get this, and then yeah. So this is our d over dt after being differentiated. 50 becomes 0, and then we substitute dl per dt into the equation, which we'll get negative 2w over L after making dw over dt as our subject. So knowing that LW, our area of rectangle, is LW, and then it also equals to 50, we substitute L with 5 inches, in which we'll obtain the value of our width. So we substitute L equals to 5 inches and width equals to 10 into the equation that we have obtained earlier just now, and then we'll have negative 4 inches per second. So since it's asking for the change of the perimeter P, the formula for perimeter, okay, we differentiate and then just substitute in the value, and that's when we obtain negative 4 inches per second. So yeah, that's for question A. The same also goes for question B, when it's asking for 10 inches, L equals to 10 in. So basically, you pretty much do the same thing all over. dw over dt equals to negative 2w over L, LW equals to 50, and then substitute 10, L equals to 10, and then you'll get W equals to 5, and then dw over dt, negative 2, yeah, negative 2 in bracket 5 over 10, and then you get the value for W over dt, and then as earlier, you substitute inside, and then you get 2 inches per second as our dp over dt. And then for question C is asking for the dimensions when the perimeter ceases to decrease. So ceases to decrease. Whenever something ceases to decrease, our dp, our rate of change, is equals to 0. So referring to question A, we have obtained this equation earlier. So we substitute in dp over dt equals to 0, and then again making dw over dt as our subject, and then substitute this, in which we have obtained also from here as well, yeah, from this equation as well. So dw over dt equals to negative 2w over L, and then we pretty much have to rearrange until we have concluded that w, our width, is equals to our length. And since our LW is equals to 50, we pretty much substitute W, which is again equals to L. So L times L becomes square, and then the square brings to the other side, becomes 5 set 2. Also the same thing applies, the same as for W, and then you'll get 5 set 2. So yeah, so both the dimensions we have obtained are L equals to 5 set 2 and W equals to 5 set 2 when perimeter ceases to decrease, indicating that our rectangle is a square.
Okay, so in this question 3, the total cost of producing X radio set per day is Rm 1 over 4 x squared plus 35x plus 35, and the price per set at which they may be sold is Rm 50 minus half x. So first is A, what should be the daily output to obtain a maximum total profit? So for the cost, I put Cx to represent the cost, and Px for the price per set. So first, we calculate the revenue by multiplying the number of units sold by the price per unit. So this is what we get. Then after we get the revenue, then we can calculate the profit by subtracting the cost from the revenue. So this is what we end up with. So to calculate the max profit, we simply just have to differentiate. As we can see here is dp over dx. Then we equals it to 0. So then we get that x is equal to 10 radio sets. So now for part B, show that the cost of producing a set is a relative minimum at that output. average cost A, average cost, I put it AX equals to CX over X, because total cost divided by the number of units. So then we get 1 over 4x plus 35 plus 25 over x. Then we simply differentiate the average cost and equals it to 0, so that x equals to 10. So to find whether it's relative minimum, we apply second derivative, which is 50 over x over 3. Then we substitute x with the answer that we obtained, which is 10. And as we can see that the value is more than 0, which is a proof that it is actually a relative minimum at x equals to 10. So the final conclusion, the daily output of 10 radio sets gives maximum total profit, and at the same output, the cost per set is minimized.
So everyone, this is question 4. Question 4 is evaluate each of the following limits using L'Hopital rule. So we're gonna look at question 1. Question 1 is this. So if we substitute 0 into the equation, we're gonna get 0 over 0, which is in indefinite form. So we can't do that. So we have to use the L'Hopital rule. So how do we use it? We differentiate the top one and differentiate the bottom one separately. The keyword is separately. And after we have differentiated, then you will substitute 0 into the x, and you will get this answer. Easy, right? So the next question, as you can see also, if we substitute this infinity into the equation, the function, you will get an indefinite form. So we can do that. So we will use L'Hopital rule. So this function and differentiate the upper number and the lower number. After differentiate, we will get this number. Yep, 6a over 2x and 8x. And if we substitute, so if we try to substitute it, we will still get an indefinite form. So if we still get the indefinite form, we will do it again, L'Hopital rule again. So we differentiate again, up and bottom, and we'll get this answer. And substitute the infinity into this answer, we will get an infinity, which is a definite form, not in an indefinite form. So it's the right answer. So the next question, this is the function that is given. If we substitute the 0 into this function, we will get this answer. This answer is also an indefinite form because 0 multiplied by infinity is an indefinite form. It's in the definite form. So we will use L'Hopital rule and differentiate the functions. If we differentiate the function separately, if we want to be easy, x is divided by ln x and negative 2x negative 3. So limit equals to this. If we simplify it, you will get this answer. Then substitute into the function, you will get 0. So the last question, limit this function. If we substitute the infinity into this function, we will get an indefinite form also. So even if we try to differentiate the answer, you will get the same answer all and over again. So the answer is this. You will get this answer. Infinity plus infinity. If infinity equals to this infinite form. So that is all from question 4.